Hello students, welcome back to Capman Academy, and today we are going to talk about the very important property of the fluid, which is known as viscosity. Right? So viscosity, if in simple language we say, it is the property of the fluid which actually causes the stickiness and thickness in the fluids. Right? And the stickiness and thickness, this is due to the bonding between the molecules present in the fluids. So the stronger will be the bonding between the molecules, the thick will be your fluid. And according to this property, different type of fluids are present. Right? As you can see here, water here, it is having the less viscosity, whereas chocolate syrup here, it is having the high viscosity. Right? And this one is also called the viscous nature of the fluids. So if we talk about its definition, then it is the internal or intensive, it is intensive property of fluids, right? And this property give rise to forces which actually resist the relative movement of adjacent layers in the fluid, right? Or if simply we say viscosity in the fluid offers resistance to fluid motion or its flow, right? So these forces, they are arises between the fluid molecules which are present in them, right? So as the viscosity high for the liquids, they actually move less. So their movement there will be less, and as the viscosity will be low, their movement will be high. As you can see here, if we take example of water, in that case water moves fast, which means it has low viscosity, which means it is less viscous. Whereas if we talk about chocolate syrup, then its viscosity here is high and it moves very slowly, right? Take another example. For example, in a solution, we have two parallel plane elements. Right? And they are moving relative to one another. And to keep them in the moving condition, we have to apply a steady force which actually maintain a constant relative speed. So that speed is called your viscous drag force, right? So in this case, if the plane elements are at distance, the elements, they are at a distance from each other, which is z, and if their relative velocity v, then the force which is required to maintain this motion, the force which I told you, which is needed to maintain the movement in the elements, that one is actually proportional. The force will be proportional to the velocity, but inversely proportional to the distance, right? So this one is actually called coefficient of proportionality, right? Or simply it is known as viscosity of fluids, and it is denoted by the symbol mu, right? So if we talk about an equation in the viscosity or its formula, then your force in a particular area, it is equal to your viscosity divided by the Z. So in this case, F here is the force which is applied, right? A here is the area over which the force is applied. Nu here, it is your fluid viscosity. V here is your velocity. And Z here, it is the distance between the two elements, right? So if we talk about F divided by A, it is also known as by another fraction which is known as tau, or known by the name shear stress, right? But now this velocity is actually varies from fluids to fluids. So then again this equation is expressed as velocity and the difference velocity gradient or shear rate between the velocity and the distance, right? So your final viscosity equation will be like this. So if we straight it down, then tau is equal to your mu and the velocity gradient, right? So this is the equation for viscosity, the fluids, right? So this one equation is known as, I'm talking about this one. So this one equation, it is known as absolute viscosity. Absolute viscosity, right? So now what is the absolute viscosity? Actually, the viscosity, it can be measured by the two types. One type is your absolute viscosity or known as dynamic viscosity. This one is measured when external forces are applied to the fluids. Right? If we talk about other type of the measurement of the viscosity, that one is called kinematic viscosity. This one is measured by resistive flow under the weight of gravity. Kinetic viscosity is expressed by the equation which is V is equal to mu and rho, where mu is your absolute or dynamic viscosity, rho is your density of the fluid, or V here is your kinematic viscosity, right? And this one is expressed in the SI unit which is known as Poisson or PI. Other units for the viscosities are M, L minus 1, T minus 1, or it is also expressed as Newton second per meter square or expressed in Pascal second, right? Viscosity, it is also depends on temperature. So if temperature of the fluid is increasing, in that case viscosity of the fluid will decrease, right? And this happens in cases of the liquids. And if we talk about the gases, in that case, as we increase the temperature, viscosity of the gases will also increases, right? So these are the important aspects of the intensive property of the fluid, which is known as viscosity. So you should know about in respect of the temperature, right? Your viscosity, how it decreases and increases in both in case of liquids and gases. So in this section, we covered about the viscosity parameter of the fluids, in which we saw its definition, right? We saw its formula and we saw how it is being affected by the temperature, right? So that's all for the today. Thank you.